Most students study SAT math like absolute lunatics. They're doing random practice questions, watching 14 different YouTube tutors, crying into a calculator, and trying to solve every problem by hand like Desmos personally insulted their family. And then they wonder why their score isn't moving. But here's the truth. SAT math is not random. It's the same patterns wearing different outfits. So in this video, I'm going to show you 5 SAT math patterns that repeat constantly on the digital SAT so you can stop walking into every question like it's a hostage negotiation and actually know what to look for. Pattern number 1 is going to be the unit decoder, and this pattern shows up about once every test. So if you know this pattern, you'll be able to get about 10 extra points every single test. So this question right here says a certain apprentice has enrolled in 85 hours of training courses. The equation 10x plus 15y equals 85 represents a situation where x is the number of on-site training courses and y is the number of online training courses this apprentice has enrolled in. How many more hours does each online course take than each on-site course? Now, the number one mistake that students make for this problem is they look at this and they're like, oh, well, there's only one equation and I need to find x and I need to find y, and one equation is not enough information in order for me to be able to find two variables. But that's not true, because they're not exactly looking for that. They're looking for you to kind of break down the existing equation. So if I go ahead and I take that equation, 10x plus 15y equals 85, and I decode this with units, then I can understand what everything stands for. So if I look at the 85, I know that the 85 stands for hours, right? So if I have hours on the right side of my equation, then on the left side of my equation, I must also have hours, right? I can't have grams equals hours, or I don't know, anything along those lines. My units must match on both sides of the equation. So if I break this down even a little bit further, therefore each of these must stand for hours, because hours plus hours would equal hours, right? All right, so now I can go even a little bit further and I can say X stands for number of on-site training courses. Number of on-site courses. So then I'm going to think about this. If this whole thing must stand for hours, and X is the number of on-site courses, then 10 must stand for the hours per on-site course. Now, I'm not told this in the problem, but I'm able to infer this because I know how to decode with units. So I'm going to do the same exact thing over here. Y, I am told, stands for number of online courses. So number of online courses. So therefore, the 15 must stand for hours per online course. And it works because hours per online course times number of online courses gets me hours, plus hours equals hours. So everything checks out. All right, so now the question is asking me, how many more hours does each online course take than each on-site course? Well, the online course takes 15. The on-site course takes 10. I'll do 15 minus 10, which is 5. And just like that, I have my answer. Now, like I said, a lot of students will look at this problem and think they need another equation or something, but 9 times out of 10, what you're doing for this exact type of situation is you're breaking down the problem and you're just really analyzing those coefficients and what those coefficients really stand for. So anytime you see a problem of this structure with one equation and they're asking you things along the lines of units from the equation, you're usually going to break it down using this method right here. Pattern number 2 is dimensional analysis, and you usually see about one of these every single test. So knowing this pattern will get you an additional 10 points. Now, if you guys have taken chemistry, I'm sure you guys know exactly what I'm talking about, and this shows up so often on the SAT, especially the problems where you have to make them squared during your dimensional analysis. So over here, I'm told that I have 4.36 square miles. So let me just go ahead and write down 4.36 square miles. And I want to find the area in square yards of this town. So my end goal is to go from square miles to square yards. So I need to go from there to there. I am given one conversion ratio. That 1 mile equals 1760 yards. So what I'm going to do is I'm going to multiply by that conversion ratio. 1 mile to 1760 yards. I'm going to put one over the other. Now the question is, which one do I put on top? Which one do I put on bottom? Well, the one I should put on the bottom should cancel out this one, because I'm looking to cancel out miles so I can have yards, right? So I'll put miles on the bottom so these can cancel out. Therefore, I must put yards on the top. I have 1 mile for 1760 yards. Put that on the top, but I have one little issue. My miles does not cancel out with square miles. So I need to make this square miles. How do I make it square miles? I literally just square it, right? So if I square the bottom, we need to think about how all of this is going to come together. Because right now, I know that these are equal, right? So if I'm dividing something by itself, I know that this, in theory, just equals 1, right? So if in theory it just equals 1, I could really just square this whole thing, right? Because 1 squared is just itself. So if I could square the whole thing, then therefore I could just square the top, and I can also just square the bottom. So therefore I'm following the laws of mathematics, and this works, and this actually checks out. And now I actually have square miles, so my square miles will actually cancel out with this square miles. And now all I'm really doing over here is I'm just doing 4.36 times 1760 squared divided by 1 squared. We don't need to do that. That's anything divided by 1 is itself. And now I'm left with the only units that actually matter, which is square yards. So once I actually multiply these out, I'm going to get 13.5 million. So my answer for this one is D. Like I said, dimensional analysis is super, super common on the SAT. You are going to see this all the time. So make sure you guys know this pattern. Like I said, knowing this will get you an additional 10 points every single test. Pattern number 3 is on unit analysis, and there's usually about 1 of these every test. So by knowing this pattern, you'll be able to get about 10 additional points. So over here, I'm given a question that says, Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5, assuming gasoline costs $4 per gallon. Which equation can Alan use to determine how many fewer average miles M he should drive each week? So the number one mistake that students make for a problem like this is they try to start thinking conceptually in their head about how to actually put all this together. How do I put miles per gallon with miles and with money per gallon in order for me to be able to find the correct equation? You can do that, but honestly, you're going to be here a long time, and that takes a lot of effort. So with unit analysis, if I understand the units of each number, I can put my units together to see if that gets me my desired result. And you're going to do this time and time again anytime you're given a question of this structure, and every single time you can just really decode the units. So what I'm going to do is I'm going to look through my answers. I noticed 2 big differences. It's either 95 or 5. Well, how could they have gotten 95, right? Maybe the 100 and the 5, but wait, hold on. The 100 is miles, the 5 is money. That has no relationship. So there's no way in the world we could even get 95. That doesn't make any sense. So another way to look at it to be able to eliminate A and C is that we're looking for how many fewer average miles M we need in order to reduce the weekly expenditure by $5. So we're looking for the amount of miles that would get us $5 savings. So therefore we do want to equal to 5. All right, so now that I have those crossed off, it's now really just a matter of, am I doing 25 over 4 or am I doing 4 over 25? So let me start with the 25 over 4. The 25 is miles per gallon. Miles per gallon. The 4 is dollars per gallon. Dollars per gallon. Times M. M is miles. So I just took all of this and I rewrote it using their corresponding units. And it's equal to 5 on the right side, and on the right side I have dollars. So if this whole thing simplifies down to dollars, then I'm good. I have my desired result. So let me try it out. I have a fraction inside of a fraction, so I'm going to do keep, change, flip. Alrighty, my gallons cancel out over here. And I do still have the times miles over here. So if I put all of this together, that's miles times miles, which is miles squared over dollars. That's definitely not what I'm looking for, and that's definitely not what I have on the right side. So that's not going to work. So at this point, I could eliminate B, and by process of elimination, we can go ahead and choose D. Now, with process of elimination, just go ahead and choose D and move on. Don't even do the work, because at this point, you're already like 2 minutes in the problem, so if you do it and it ends up not being D either, then you have to restart the problem all over, and you've already spent so much time on it that it's not worth any more of your time. And if you do get it and it was right, then it was a waste of time anyway. So that's one good little pacing strategy right there. But anyways, we're going to do it for the sake of the video so you guys can see how to do the unit analysis over here. So I'll start with the 4. 4 is dollars per gallon. Divided by 25, and the 25 is miles per gallon. Miles per gallon times M, which is miles. and this should equal 5, which is dollars. So I will do keep, change, flip times the miles, and let's see how that works. Miles cancels miles, gallons cancels gallons, and check it out. I have dollars equals dollars. I did not have to conceptually think about this and how to actually put all of these different things together. I can just use units to tell me the correct way to put them together. And you can do this for a lot of different problems on the SAT. It's a super powerful strategy just by analyzing the units. Pattern number 4 is going to be on an SAT trap language. There's usually about one of these every test. So again, knowing this pattern should get you about 10 additional points. So this question says that the cost of renting a large canopy tent for up to 10 days is $430 for the first day and $215 for each additional day, which in the following equations gives the cost Y in dollars of renting the tent for X days, where X is a positive integer and X is less than or equal to 10. Notice how I'm told that X is less than or equal to 10 and they told me that they're renting it for up to 10 days. That's redundant information, so you don't need that. The only reason they include that in there is really just to kind of throw in some unnecessary information that you don't need. All right, so this is my critical information. $430 for the first day, $215 for each additional day. What most students do over here is they'll look at the answers, they'll see that they're all on MX plus B, and they'll say, okay, well, my M is $215, my B is $430, so therefore I'm just gonna go ahead and choose D as my answer and move on. But that's wrong, and here's why. They have some trap language in here, and what that trap language is right over here, $430 for the first day. So when students read first day, they're like, oh, that's the starting point, and the starting point is my y-intercept, which is my B value, but that's not true, because if it's the first day, then the amount of days equals 1. And X is the amount of days, so this would be 1, comma, 430. That's not a y-intercept. The y-intercept happens at 0, comma, 430 or what have you. This is at 1, 430, which is not a y-intercept. So that's the trap language right there. That is super common trap language that you will see again on other SATs. And anytime you see that in the future, just know that it's not referring to the y-intercept. Now, you're usually going to see this question in the hard region, which is going to be 17 through 22 of module 1 or like 13 to 22 of the hard module 2. All right, so at this point, you know that the slope has to be 215 because it's 215 for each additional day, so it has to be this one or this one. And you know that the B value cannot be 430 because that happens at 1. So these two are out because of incorrect slopes, and then this one is out because of an incorrect B value. So at this point, you could just say that A is your answer. But if you guys want to know what to actually do from here, well, I can essentially just get myself 2 quick points. And if you guys did watch the video I made on Desmos tips, I do go over this topic over there in that video. But I have my first point at 1, 430, and then I know it's 215 for each additional day. So 1 additional day, I'll add 215, and then I'll just take this table and I'll just go to Desmos and I'll just plug that into Desmos. And when I do, I just tap this lovely button right here that says add regression. It connects my points. Not only does it connect my points, but it also gets me the equation y equals 215x plus 215. So just like that, my answer is A. Again, something to watch out for in the future. Very common wording from the SAT. Pattern number 5 is going to be on exponential equations. There's usually about 2 of these on every single test. These are super, super common. So knowing this pattern would get you about 20 additional points. So what we're going to do is we're going to forget about this problem for 1 second. And we're just going to cover exponential equations and how they work. So let's imagine that I have the exponential equation y equals 5 times 2 to the power of x over 3. And what I'm going to do is I'm going to make a quick XY table over here so we can just understand how this works. And if I do that, I'm going to go ahead and I'm going to start off with a 0. So I have 0 over 3, which is 0. 2 to the 0 is 1. 5 times 1 is 5. And then I want to think about the next logical number that I should be plugging in for x. A lot of students are going to say 1, but 1 isn't good because I'll plug in 1, I'll have 1 over 3. I don't know how to do 2 to the 1 over 3. So a better value for x to plug in afterwards is going to be 3, because if I do 3 over 3, that's 1. That gets me an exponent of 1. I know how to do that. 2 to the 1 is 2 times 5, 10. The next logical number for me to plug in for x is going to be 6, because 6 over 3 is 2. 2 to the 2 is 4 times 5, 20. All right, so let's understand what all of these stand for. 5 is my very first number. It's my initial. That initial is going to be right there in front of the parentheses. And then my rate of how I get from one y to the other is going to be 2. I'm constantly multiplying by 2. That comes from inside the parentheses. And then lastly, my interval for x, I see that it jumps by 3s, and that comes from your denominator right there. And the reason why is because let's say that I take this exponent, x over 3, and I set it equal to 1, because every time this 2 is going to be multiplied is going to be like 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. It's whenever that exponent is a whole number, right? So if I take the exponent and set it equal to 1, a whole number, then x would have to equal 3, right? That's kind of why it's in intervals of 3. All right, so now that we went over all of that, now we're actually good to go ahead and try out this problem. Really important to understand those 3 things that I just covered. That's going to show up so often on the SAT. But this says that the function P models the population in thousands of a certain city T years after 2003. According to the model, the population is predicted to increase by 4% every n months. What's the value of m? I don't even have months in the problem. I just have years. But I do know that I'm directly working with the exponent since t, the amount of years, is in my exponent, and I'm looking for the amount of months. So they're clearly related. Well, from what I just covered, I know that the interval for x, or in this case t, and how often t happens is really just going to be whenever I get t to equal, I'm sorry, not t, whenever I get the exponent to equal 1. Whenever I get the exponent to equal 1, that's going to be an interval for t that's going to actually make it work. So what I'll do is I'll take 6 over 4t and I'll set it equal to 1. What I can do over here is I can get rid of 6/4 by multiplying by 4/6 on both sides. So this cancels out, and now I have t equals 4/6. All right. So now I know that the intervals for t are going to happen every 4/6. So I will have my first 4% increase happen at 4/6 of a year. And I can visualize this because let's say I actually go ahead and plug in a 4/6. Let's see how this works. Plug in 4/6. 6 over 4 times 4 over 6 is 1. So now this is just 260 times 1.04 to the power of 1. So now I'm actually taking the 260 and increasing it by 4% just one time. So that's exactly what I wanted. I really just confirmed my work over here, and I am indeed on the right track. So now that I know that the interval for t is going to be every 4/6 of a year, I'm just looking to convert that to months now. So n is really just months, 4/6 of a year, which is 12 months. So I'm taking 4/6 of 12 months. 12 over 6 is 2 times 4 is 8. All right, so like I said, really, really, really common pattern. You guys are going to see this again over and over and over. And it's not always going to be asked this way. Sometimes you guys are going to be asked about the initial number. Sometimes you guys are going to be asked about the rate. Sometimes you guys are going to be asked about the interval for your exponent. Those 3 things, really important that you understand how to work with all 3. So there you go. SAT math is not some mysterious ancient curse created in a basement by college board goblins. It's patterns. And once you start recognizing the patterns, the test gets a whole lot less terrifying. Now, if you want more help, join our free SAT Strategy Lab community. You'll get free Friday group classes, free SAT courses, and you can ask questions when the SAT starts making you feel like your brain is buffering on hotel Wi-Fi. Link is below. Come hang out with us.